Hello, my friend. Nice to meet you again at the YouTube. Today we will back to the questions for the digital circuit analysis. And I think this is the last question for this testing. And it's about the finite state machine, okay? Finite state machine. About this concept, there are basically two types of finite state machine. The first type is Moore. The second type is Mealy. Okay. And for the type of Moore FSM, the output state has only the relationship with the input. However, for the Mealy type of FSM, the output or the next state is related to both the current state and the input. All right. And as to this question, we can see there are basically four states. All right, S0, S1, S2, and S3. We use 00 stands for the S0, 01 stands for the S1, 10 stands for the S2, and 11 stands for the S3. Okay? And we can also get the information that the next state has only the relationship of the input. Okay? So if currently we are at the S0, and if we will go to the next state S1, the only trigger is the input 10, which means the next state S1 has no relationship with the previous state S0. So obviously, this state machine is type Moore. Okay, type Moore. All right. So let's firstly clarify the type of the question for the finite state machine. And most of the case in the Mealy type of state machine, it has less states than the Moore state machine. All right. So let's back to the question. The first question is let us to fill this table. This table has mainly three branches. The first one is about the present state. The second is about the inputs, and the third one is next states. So we will write it like here. So Q1 and Q2, Q1 and Q0 means the current or present states. And the A and B means the input. All right, this is input. This is current states. Okay, and for the D1 and D0, it means next state. All right. Okay, we will fill this table. So we back to the transition table. So we start from the S0. Okay, and we can see there only three arrows at out of or point to the next state from the S0. So we can see it like this. So first one is 00, which is S0. When the input is 10, okay, 10, it will choose the next state, which is 01, which is state 1, okay? All right. And we can see if the input is 00 or 01, it will return to itself, okay? So the current is still state 0, and when the input is 00 or 01, it will choose itself, okay? 00, which is state 0. All right. And the third one is when the input is 11. the state machine will be transited from 0 S0 to S2. Okay, so it's 0 0, which is state 0, and the input is 1 1, and the next state will be 1 0. Okay, 1 0, which is state 2. Okay, those are all the three possibilities from the state 0 to the next state. Okay, next we will start from status 1. Okay, state 1 S1. So it's 0 1 for state 1. We can see there are only two arrow point outside. Okay, so if the input is 0 0 or 0 1, okay, 0 0 0 or 0 1, it will go to the state 0. Okay, which is 0 0 state 0. And for the other case, we still start from 0 1, which is state 1, and when the input is 1 0 or 1 1, okay, 1 0 or 1 1, it will went to the state 3, which is 1 1 state 3. Okay, that those are all the two possibilities that start from state 1 to another state. Okay, now we will focus on the state 2. Okay, state 2, which is 1 0 state 2. We can see there are only two arrow point outside. Okay, yeah, as well. So we first go to this thing when the input is 0 0 or 1 0, 0 0 or 1 0. It would to 0 0, which is state 0. Okay, and another one is this one. Okay, we start from 1 0, which is state 2 as well, and the input is 0 1 or 1 1. It would to the state 3, which is 1 1 or state 3. Okay, finally, we will look at the state 3. Okay, state 3 is 1 1 state 3. We can see there are two output negative state. One is 0 0, this one, and one is this one. Okay, so we look at this one. When the input is 0 0 or 1 0, the output will be 0 1, which is state 1. Okay, and the next and the final one is the original state is S3, and when the input is 0 1 or 1 1, it will go to state 2, which is 1 0 state 2. All right, so all these possibilities are the relationship between the current state to the next state. The only trigger or relationship to link the current state and the next state is the input signal. So it's a very classical Moore type of finite state machine. Okay, so I think we finished the first question. And the second question is asking us to use K-map to get the minimized expression for D1 and D2. So I think this will be quite straightforward because from the previous question, we get the expression for the D1 and the D2. Okay, so the D1 and the D2 can be decided by the Q1, Q0, and AB. Okay, so we will write the solution for the part B like this. So firstly, we will write the K map for D1. Okay. All right. So we will write the key map like this. It is Q1 and Q0, and this is input signal A and B. Okay, all right. Okay, so we will get the key map like this. So as we illustrated in the previous questions, for the Q1 and Q0, it's 0, 0. Yeah, 0, 1, 1, 1, and 1, 0. Okay, that's 4 possibilities. For AB, it's also 0, 0, 0, 1, 1, 1, and 1, 0. Okay, so we will go in. We will go to field ones in this table. So which is ones? So we will find the ones. Okay, so which is ones? This is 1 for D1. Okay, this is for D1. This is for D1. This is for D1. Which means D1, the value of D1 is 1. Okay, yeah. So we can get the Q1, Q0, which is 0, 1, 00, AB is 0, 0, 0, 1. Okay, this one is 0, 0, 1, 1. Okay, we just fill that the beneath table from this combination. All right, this combination. Okay, so we will finish it like this. This is 1, 1, 1, 1, 1, 1, 1. All right, all the other table should be filled 0. I will not write it down because I think you already know it. All right, so we just draw the cycle to make the combination. So obviously, these 4 can form a combination. These 4 can form a combination, and these 2 can form a combination. All right. So the next thing is just straightforward. So D1 means from the first combination, we will cancel all the rows and keep the value, so which is A, B. Okay. For the second one, this 4, so it is Q1 and B. All right. And for the third one, which is this one, it's Q1, not Q1, Q0 and A. All right. This is a final expression for D1. All right. Similarly, we will write the K-map for D0. We just repeat the similar way. We use another color. Okay, we use this color. We will find the values is 1 for D1. So this is 1, this is 1, this is 1, this is 1. Okay, and we just build the combination here, here, and here, 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 and here, here. So we found the combination and feed 1 in the similar table. Okay, so we will draw the table similarly. Q1, Q0, A, B. Okay. All right. This is 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. All right. We just fit the ones into the table. So this should be 1, 1, 1. This is 1, And for this thing, this is 1. All right? I think that's all the ones from this table. Okay. Now what we need is just to draw the combinations. So obviously, we can draw the combination like this. Okay. And these two, and these two. Okay, we can draw 4 combinations to get the final expression for the D0. All right. So we will write the final answer like this: Q1 Q0 not B plus Q1 Q0 not B, and plus Q not Q1 Q0 A, and plus not Q1 A not B. So I think that's the final solution for this question. So I think we should pay special attention to the concept of the finite state machine. Yeah, and I think that's all. Thank you very much. Hope you enjoy the day and the explanation. Let me know if you have any further questions. Bye bye.